GPS, Global Positioning System, is a satellite-based navigation system that allows users to determine their location, velocity, and time. The system consists of a network of satellites, ground stations, and receivers that work together to provide accurate location information to users around the world. In this article, we will discuss how GPS works in detail, including the history of the technology, the principles behind its operation, and its many applications. History of GPS. The development of GPS began in the 1960s when the U.S. Department of Defense launched the first satellite navigation system, called Transit, to aid in the navigation of submarines. Transit used a system of Doppler shift measurements to calculate the position of a submarine by measuring the time it took for signals from multiple satellites to reach the receiver. The technology was effective, but it had limited accuracy and was only available to military users. In the 1970s, the U.S. Department of Defense began development of a new satellite navigation system called Navstar GPS, which would use advanced technology to provide accurate location information to users around the world. The first GPS satellite was launched in 1978, and the system became fully operational in 1995. Since then, GPS has become a ubiquitous technology, used in everything from navigation systems in cars and airplanes to smartphones and fitness trackers. Principles of GPS. GPS works by using a system of satellites in orbit around the Earth to transmit signals to a receiver on the ground. Each satellite broadcasts a signal that contains information about its location, as well as the time the signal was transmitted. The receiver uses this information to calculate its distance from each satellite, and then uses this information to determine its own location. To calculate its distance from a satellite, the receiver measures the time it takes for a signal to travel from the satellite to the receiver. Because the signal travels at the speed of light, this time measurement can be converted into a distance measurement using the equation distance speed x time. However, because the receiver doesn't know the exact time the signal was transmitted, it must first synchronize its clock with the satellite's clock. This is done by comparing the timestamp on the signal with the receiver's own clock and then adjusting the clock to account for any difference. Once the receiver has calculated its distance from multiple satellites, it can use a process called trilateration to determine its exact location. Trilateration is a method of determining the intersection of three or more circles or spheres in 3 dimensions to pinpoint a location. In the case of GPS, each satellite broadcasts a signal that creates a sphere of possible locations around the satellite. By intersecting these spheres, the receiver can determine its own location. To increase accuracy, the GPS system uses a technique called differential GPS, which compares the signals received by multiple receivers to determine any errors in the signals due to atmospheric interference or other factors. By comparing the signals received by multiple receivers, the system can determine the location of any errors and correct for them. Applications of GPS. GPS has become an essential technology in many industries and applications, including navigation. GPS is used in navigation systems for cars, boats, airplanes, and other vehicles, providing users with accurate location information and directions. Surveying. GPS is used in surveying to accurately measure distances and locations, making it an essential tool for civil engineering and construction. Agriculture. GPS is used in precision farming to help farmers optimize crop yields by providing accurate location data for planting, fertilizing, and harvesting. Search and rescue. GPS is used in search and rescue operations to help locate lost or injured individuals in remote areas. Military. GPS is used by the military for navigation, target tracking, and other applications. Geocaching. GPS is used in geocaching,